Welcome back. Before I start this tutorial about how to create a pure data flow, please note that it's going to be more like a proof of concept than a practical solution for anything. It will show off some capabilities of LabVIEW, so hopefully you will still find it interesting. First, I'm going to create a class for the data flow called numberFlow. But it will only contain a string, which will hold the name of a queue. Therefore, I will label the control queueName. And I'm going to save this class and its member VIs in a separate directory. Then right-click on the class item, choose New and VI for data member access. I only want two VIs for this class, one for reading the string and one for writing the string. And I don't need any polymorphism or any error handling, so I'll turn that off and then create the VIs. Next, I want to change the wire appearance of this class. I'll do that by right-clicking on the class item, choosing Properties and Wire Appearance. I want to give the wire the appearance of being a flow of double precision numbers. Now it is time to start building the chart XControl. I'm going to save my new XControl in a directory called chart, and I will also name the control chart. As soon as I've gotten the other files out of the way. First, I want to change the data type of this XControl by opening the data.ctl control and replacing the existing control with my new numberFlow class. And now I can start working on the facade VI. I don't want this text, but I do want a waveform chart here. Minus the label and plot legend. In this block diagram, and particularly this event structure, is really where everything happens in an XControl. This control should always be an indicator, so therefore I'm going to go to the display state change event. There I want to unbundle the container state input using the unbundle by name function and get the reference number of the control. By right-clicking on the connector, I can choose Create and find the indicator property of this control. By right-clicking on the property and choose Change to Right and adding a Boolean constant set to true. Then copying these functions, switch to the direction change event and pasting them there and attaching them to the container state input. I can make sure that this control will always stay an indicator. And now time to go back to the data change event and create the main functionality of this XControl. I want this operation to run only once when the XControl receives a value during runtime. I'll ensure that by again unbundling the container state cluster and this time choosing the run mode boolean. Then it's time for the main piece of this puzzle. I go to the data communication palette and from there choose the actor framework palette. There I choose the launch actor VI. This VI uses 3 objects. It wants an object that inherits the actor class. It wants an enqueuer through which the object can send messages. And it returns an enqueuer through which the object receives messages. The enqueuer on which the actor object sends messages is called actor to caller enqueuer. This is either an enqueuer belonging to another actor or it's an enqueuer belonging to a standalone message queue. Since I'm only launching one actor, I need to go to the actor framework palette and choose the message queue palette from there and drag and drop an obtain message VI and a read enqueuer VI. Note that my actor object will not send any messages, so this message queue won't actually be used for anything. The caller to actor enqueuer, however, is. This message queue is created by the launch actor VI and it will be used to send messages to my actor object. In order to get the enqueuer to my caller, I need to store it in a queue. And the name of this queue will be sent to the XControl at runtime. So I drag and drop the read queue name member VI from the number flow class. Then go to the synchronization palette and the queue palette where I choose obtain queue. Then name the queue. Right click on the connector and go to the queue palette to get the enqueue element function. Then rearrange the diagram a bit. Set the queue data type and finally enqueue the enqueuer. And now the time has come to start concentrating on the actor object. The object must be able to access the waveform chart, and it will do that by using a reference to the chart. The object will store the message queue and the chart reference. Therefore, I'll right-click on the wire and the connector and make 2 controls. These controls will go on another front panel. Therefore, I will switch to the facade front panel and then cut the controls out. Now to the actor object, which will be a new class. I will call it number actor. On the front panel of the numberActor.ctl file, I will paste the controls that I just cut out, make a quick rename and add them to the cluster. And then I can save the new class to its own directory. After saving, it is time to make the new VIs for data member access. The message queue control will get a VI only for writing, and nothing else needs to be added. Here's what the front panel looks like for the VI. I need a data member access VI for the chart as well, and this too will only need a VI for writing. When that is done, I can go back to the facade block diagram for the chart. Thanks to having added the launch actor VI, the actor class has been loaded into memory as well. So when I right-click on the number actor item and choose Properties, I can go to the Inheritance tab and click on Change Inheritance. Here I can switch inheritance from the basic LabVIEW object to the actor class. And here you can see the new inheritance. Now it's time to drag and drop the number actor onto the block diagram, as well as the new data member access VIs. After I've wired everything, the XControl is almost finished. When I wire the object to the launch actor VI, you will notice that the connector is marked with a red triangle indicating a typecast. In this case, it's because I have wired a subclass to the connector. For the finishing touch, I want to rearrange the front panel, right-click on the waveform chart and choose Fit Control to Pane. This will automatically tick Scale Object with Pane. And now there's only one thing left, and that is to right-click on the XControl item, choose Properties and click on Edit icon. I want this XControl to look like a chart on the block diagram. So first I'll make a white background with the filled rectangle tool and then paste the chart icon from a screen grab of the facade block diagram. Whether the new icon should be copied to the other files, I guess, is a matter of taste. Now that the XControl is finished, I will end the video here. In the next one, I will show you how to create the caller and how to make the message passing, and also some things about error handling.